All right, so this is our Unit 2 biochemistry notes, and so we're going to be talking about molecules that make up living things, and so that's why it's called biochemistry, because bio means life, and with chemistry we're talking about molecules. Now, a little bit of background about molecules. Molecules are built from atoms, so when atoms bond together, then we form bigger structures, which are called molecules. Now, how these atoms bond together or link together, we're going to talk about, there's two main types of bonding that we're going to find between atoms of our molecules. So we have covalent and ionic. Let's first just talk about what we mean by a covalent bond. If you have two atoms that are bonded together by a covalent bond, then what that means is they are sharing electrons. So I'm going to draw an electron. Now I'm going to put a minus behind it because electrons have a negative charge. And what I mean by sharing electrons is sometimes the electrons will orbit around one oxygen atom and then sometimes they orbit around the other one. So you can see that these two atoms of oxygen are sharing an electron. Now there's two ways that an electron can be shared. So there's two types of covalent bonds. We have a nonpolar covalent bond and a polar covalent bond. In a nonpolar covalent bond, these electrons are being shared evenly. So that's what I just diagrammed above. We have electrons being shared evenly. Let's take a look over here between these H's and O's. Electrons are being shared. So let's put an electron here. So it's being shared. It's going around both the oxygen and the hydrogen, but it's not being shared evenly. So see how the electron is orbiting more around the oxygen than it is around the hydrogens. So the electrons are still being shared, but they're being shared unevenly. Now, when that happens, because electrons spend more time around the oxygen, if I had the electrons freeze, just stop where they're at in orbit, you would see a large amount of electrons here around the oxygen. So when you have atoms and they're sharing electrons unevenly, what can happen is this molecule can develop positive and negative charges in different areas. So since there's more electrons around this oxygen, we're going to say that the oxygen becomes partially negative. That's what this sign right here means. I'm going to mark through this one because it looks like it's incorrect. So we say that the oxygen develops a partial negative charge. And since there's less oxygens around the hydrogen, we say that they develop a partial positive charge. So again, it's kind of a funny looking 8 there, figure 8, and then you just put a plus behind it. All right, so we're going to say that these two oxygens are bonded together by a nonpolar covalent bond. And then here in this water molecule, because this is H2O, the H and the O, those are held together by a polar covalent bond. So again, we have atoms sharing electrons in a polar covalent bond, but they're sharing unevenly. Okay? So covalent means sharing, nonpolar means evenly shared, polar means unevenly shared. Now something to help you remember that in polar covalent bonds, the electrons are being shared unevenly, is these symbols that you wrote there, those are called the poles. So we say poles develop if electrons are being shared unevenly. So if you see a molecule and it has partial positives written in some areas of the molecule and partial negatives, then that just means electrons are being shared unevenly. Those poles have developed, so this is a polar molecule. So a classic example of a molecule that is a polar molecule is water. H2O is a polar molecule because it's bonded together by polar covalent bonds. Now, you probably have seen that oil and water don't mix, and that's because water is polar and oil, which are fats, which are lipids, so let's add oils here, they're nonpolar molecules. And polar molecules, such as water, won't mix with nonpolar molecules like fats or oils. So let's indicate that down here, and there's a rule that kind of describes nonpolar will dissolve, well, these two will not interact. Like dissolves like. So what we mean by that is nonpolar molecules will interact with other nonpolar molecules. So like dissolves like, or like will interact with like. Polar molecules will interact with other polar molecules. So that's why if you put oil and water together, so let's indicate these are, this would be like oil. Here's some water molecules. You can see that they separate out. So these nonpolar molecules, they'll interact with each other, but they won't interact with these polar water molecules down below. Like interacts or like dissolves like. Now we're going to go back, we're going to go to our second page now, and then we'll come back to page 1 here in just a second. So let's review a little bit about what we learned about water molecules. So we said in a water molecule, the electrons are being shared, but they're being shared unevenly. So let's draw the electron as orbiting, those are orbiting more around the oxygen, every now and then around the hydrogen. So the bond that's keeping the H to the O, so I'm just kind of drawing a line there to represent a bond, that is a polar covalent bond. And because those electrons are being shared unevenly, the oxygen is going to have more of a partial negative charge, and the hydrogens are going to have more of a positive charge. Now you're going to have to draw a water molecule and show me the poles that develop and the atoms. And if you remember that water looks like Mickey Mouse, so Mickey has a round nose, so let's put a round nose on there. So that's going to help you remember that this is oxygen. So the two other parts are the hydrogen, because remember water is H2, so there's 2 hydrogens and 1 oxygen. If you put a mouth on Mickey, that's going to help you remember that the oxygen side gets more of a partial negative charge to it. And so then those hydrogens get more of a partial positive charge. All right, so hopefully you can recognize that I have a water molecule here. So again, this oxygen is a little more negative. The hydrogens are a little more positive. Water is a polar molecule, and these are polar covalent bonds. Now, you can see here, here's another molecule, and it has those poles as well. It's got the symbols for the poles. So that must mean that this oxygen and hydrogen are sharing electrons, and they're sharing unevenly. And so we're getting those partial charges. So anytime, again, you see partial charges, you know that you're looking at a polar molecule. So let's indicate that's a polar molecule. And then, of course, water is a polar molecule, so let's indicate it's a polar molecule. All right, and we already talked about like will interact with like. So polar molecules will interact, they're attracted to one another, and it's because they have these charges that will be attracted to the charges on the other. So notice this partially positive hydrogen is attracted to the partially negative oxygen. And when this occurs, that's a bond. It's called a hydrogen bond. So when you get 2 polar molecules close to one another, that attraction is called a hydrogen bond. So here I have 2 water molecules. You can see there's a bond between them. Again, water is a polar molecule. When you get them close to one another, those partial charges that water has, that bond between them, that attraction between them, is called a hydrogen bond. So this is a hydrogen bond, and you can call it an H bond, because H is the symbol. Sometimes it's written like this, H bond, for a hydrogen bond. Notice that our hydrogen bond doesn't form between 2 hydrogens, because remember the hydrogens are partially positive. They're not going to be attracted to each other. Opposite charges attract. So the hydrogen of this water molecule is going to form a hydrogen bond with this partially negative oxygen that's on a different water molecule. Now, whenever we have molecules being attracted to water, we have another term for that. We say that they are hydro, remember hydro means water, philic. Hydrophilic. That means attracted to water. Since they're attracted to water, what that means is water will be able to dissolve them. So we can say hydrophilic or polar molecules, they are water soluble. If you put them in water, they will dissolve. So if you take some ammonia and you add it to water, since water is a polar molecule, so let's indicate polar molecule, and you can tell here that ammonia, because it has poles, see the partial negative and partial positives, so it is a polar molecule as well. Polar molecules will interact with other polar molecules. Those opposite charges attract, and that's called a hydrogen bond. So we would say ammonia is hydrophilic. It's also water soluble. If you add it to a beaker of water, then it's just going to spread out and dissolve evenly throughout that beaker of water. Now we did mention that water will not mix with oils and other lipids. And again, that's because lipids are nonpolar, and nonpolar will interact with nonpolar, but nonpolar won't interact with polar water molecules. So molecules that are not attracted to water, we say are hydrophobic. So vegetable oil, that would be hydrophobic. If you add it to water, it doesn't mix. Now, if we have these molecules, there's no poles, so they're nonpolar. They are not attracted to water, so water can't dissolve them. But they can be dissolved, but it's going to have to be by a different type of solvent. So we say that these molecules aren't dissolvable in water, but they are lipid soluble. So to kind of give you an example of, if I take a permanent marker, I think I have one around here. This is a permanent marker. Okay, so this permanent marker won't wash off with water, and that's because it is a non-polar substance. So if I put a non-polar marker, like let's say on my whiteboard, if I want to get it off, then I can't use water because this is not water soluble. I'm going to have to use something different to dissolve this permanent marker. I'm going to have to use a different solvent. So this nonpolar molecule is lipid soluble, but it's not water soluble. Let's go back to page 1 of our notes real quick. Because really I've just been talking about polar and nonpolar molecules. So let's now look at over here this other type of bond that can form between atoms. If an ionic bond is occurring, so this is an ionic bond, what is happening is these two atoms were not sharing electrons. One wants to completely give up an electron, so it will donate it to this other one. So we say that the sodium is donating the electron, and then the chloride is accepting it. So now if I take this molecule and I put it in water, ionic bonds are pretty weak, and this ionic bond will break, and our sodium and our chloride move apart. So you can see them right here. Remember, electrons have a negative charge. So if this sodium atom delivered or donated an electron to the chloride ion, this chloride ion is going to have an extra electron. It's going to have an extra negative charge. So that's why we write this chloride ion with a minus behind it, because that means it has an extra electron. It's now got a negative charge. Since the sodium gave up an electron, it's now got a positive charge. And these are called ions. So anytime you see something written and it has like a plus or a minus behind it, then we consider them ions. So K stands for potassium. And if I write a plus behind it, that is a potassium ion. So that means the potassium atom has given up one of its electrons. Okay. All right, so notice that if we take an ionic compound, so let's indicate this is an ionic compound, and that just means that we've got atoms held together by an ionic bond. Again, that's a weak bond. If we take this ionic compound and we put it in water, look at what happens. Because the sodium has a positive charge, the water is going to be attracted to it. Now, not all of the water, but those partially negative oxygens are going to be attracted to that positive ion. So you can see these water molecules surround the sodium ion. Over here, this chloride ion has a negative charge, so water is attracted to it. Now, not all of the water, but those partially positive hydrogens will be attracted to that negative chloride ion. So water molecules will surround ions of ionic compounds, and this is the reason why they are dissolved in water. So if you add NaCl, that is table salt. If you add table salt to water, it dissolves or disappears, and that's because it breaks apart and then it becomes surrounded by these water molecules, and it keeps these two ions separate so they don't reform back into that salt compound.